In this video, we're going to look at finding the stationary points of an equation and then deciding whether those stationary points are maximum or minimum points. So the first thing we're going to do is we're going to differentiate the function, because at a stationary point, the gradient is equal to 0. So we're going to find dy by dx and set that equal to 0. So let's start with dy by dx. Remember, when we're differentiating, we bring down the power and reduce the power by 1. So this is going to give us 3x squared minus 12 for our dy by dx. So as I mentioned, at our stationary point, dy by dx is equal to 0. So we're going to set 3x squared minus 12 is equal to 0. And we're going to solve this. Now, we could solve this by factorising or by rearranging in this case. So if I add 12 and divide by 3, I can now square root to get x is equal to plus or minus 2. So I've got two x coordinates. Now I need to find the y coordinates that correspond to these. So to find the y coordinates, I'm going to come back to the original equation and substitute these values in. So when x is equal to positive 2, we have y is equal to 2 cubed minus 12 times 2 plus 4. So y is equal to minus 12. And then when x is equal to minus 2, we have the same, but with minus 2 cubed minus 12 times minus 2 plus 4. So y is equal to 20. So this means I've got the two turning points. I've got 2 minus 12 and I've got minus 2 and 20. Now there's a couple of ways we can check whether these are maximum or minimum points. In this video, I'm going to use the shape of the graph to help me decide if it's a maximum or a minimum. So this is a cubic graph and it is a positive cubic, and that means it's going to have a wave shape that goes up first and then down. So this means that the first coordinate that we have is going to be a maximum point and the second coordinate is going to be a minimum. So I'm going to have a look at my 2 points, and the one with the smaller x value is going to be our maximum. So in this case, the minus 2 is a maximum and the positive 2 is a minimum.